So he breaks this down in like, here's how you do it if the cross section is a square. Here's how you do it if the cross section is a rectangle. And tomorrow it'll be here's how you do it if it's a semicircle, and here's how you do it if it's a triangle. But they're all like the same general idea. So to me, it's way easier to remember just the general formula, which is, I don't know where you want to write it in here, is number 5. I'm not going to use this. So cross that out. And basically what I want you to know is volume is the integral of area. And that can happen with dx's or dy's. So I'll kind of go through both. So if you have, is there a place for you guys to write in there? Before it? Okay. So I look at it like this. There's two ways this can happen. The volume is either going to be bounded on the left and right, and those are x values. You're going to integrate the area multiplied by dx. This is what happens if the cross section is perpendicular to the x-axis. So like that cross section there, and then you'll have shapes coming out of it. Poor attempt at drawing. And then there's the other version of it, which is if everything's in y's. So the other one is right down here. Would be from bottom to top. And now those are y values. You're still going to integrate the area. Now you would multiply dy. Everything that goes in there. Look up top. Like these are all x values. You're perpendicular to the x-axis. Like all x's up there. So this is going to be all y's. Lower and upper y value. Your area is going to be in terms of y times dy. And we use this if the cross sections are perpendicular to the y-axis. And then you'll need to know some area formulas. I think you're probably fine, but square, rectangle, equilateral triangle, which will be right triangle, 1/2 base height, semicircle is like 1/2 pi squared. So I'm just going to start doing a couple. I think you will pick up what we're doing. Start with 1. So each cross-section perpendicular to the x-axis is a square. So first I'm going to draw a cross-section perpendicular to the x-axis. How big is that? How long is that line? Don't worry about equations, just in general. How long is that line? It comes on the x squared minus this. How hard? Yeah, that's fine. Good. So this distance is just top minus bottom. And over here is top minus bottom. Over here is top minus bottom. Over here is top minus bottom. When you add up all of those top minus bottoms, you get a bunch of little teeny tiny squares. When you add up the area of all those, you get a bottom. So your squares are kind of coming out this way. So I would say we're going to integrate from. Is it okay if I just say 0 to 1 without proving to you that that's 0 to 1? So it's from 0 to 1. The area. So I'm going to show like a bunch of steps that you probably don't really need to show, but it's my way of explaining it. So I want to integrate the area. Well, the area, it's a square, right? These are all squares. So the area of a square, I want to use S because it looks like a 5. Let's say length square times dx. If it was a triangle, you'd put 1/2 base square. 1/2 base times height. If it was a semicircle, you'd put 1/2 pi square. You're just putting the area formula in there. And then, what is the length of every single square? On the side of every single square? No. Gavin, how far is it from there to there? Top minus bottom. Isn't that the side of the square? So how far is this distance here? It's still top minus bottom. It's just coming out the top instead of going sideways. So your integral will be from 0 to 1 of the length of the side squared. But the the length of the side is just top minus bottom. So it's going to be square root of x minus x squared. So take a second, process that. Let me know if there's any questions on what I'm doing. We'll do a few more. I know it's like right. X squared is a parabola, right? So x squared goes like that. Like if you take a number between 0 and 1, say 0.5, and you square it, it gets smaller. Like 0.5 times 0.5 is 0.25. You square root it, it gets bigger, so that's why the square root is like that. Okay, let's take a look at 2. And I'm going to skip through. Is that what's still written? I'm not worried about, like, this is essentially running down the area of a square and the area of a rectangle. I'm going to hope that you guys know those. That's what we're doing in geometry. If you need help on area, come to my geometry class. What? Is a square a rectangle? Is a rectangle a square? Okay. Now we are perpendicular to the y-axis. So this, if we're perpendicular to the y-axis, everything we put in our equation has to be y. So we're going to integrate from low to high, y value to y value. We got to get it in terms of y, so solve for x, and then times dy. So this is y equals the square root of x, but I can't put the square root of x into this equation because this is going to be y. So the version we're going to use is x equals y squared. That's the top one. And then this bottom one is y equals x squared. But that's in terms of x. I can't put in terms of x into a y equation. So I've got to get it in terms of y, which means solve for x. So I actually get plus or minus the square root of y, but because the x values are positive over here, I can just leave it as, I don't have to put the plus minus because the minus part is over here, and I'm not looking for that. So the volume is, everything in here has got to be a y value. So the low y value to the top y value, it's still 0 to 1, because this is 1 up a 1. And then I'm going to kind of shortcut it. The area of a square is length squared, right? So that's a big L. I'm going to replace it in a second. That's a really big L. So the area is length squared. What is the length of any cross section perpendicular to the y-axis? So what is that length right there? Right minus left. So that if you're going perpendicular to the x, it's top minus bottom. If you're going perpendicular to the y, it's right minus left. All I'm doing is in place of that L, the length of every one of those sides of a square is the right-hand equation minus the left-hand equation. I can't do that. Gotta put y's in here. So the right-hand equation is the square root of y. The left-hand equation is y squared. I forgot the times dy. And that'll be it. You can type it in, but most of these just say just set up. But if you had to type it in, you guys know how to do it. Questions on that? So you really got to pay attention to, like, is it perpendicular to the x or perpendicular to the y? Because that's essentially telling you what variable you should be working with. Yeah.
How come when it's the positive square root of x, it's y values?
So what I don't know if I understand your question right, but if y is 9, so there's somewhere. That happens when x equals 3 and x equals negative 3. I just don't care about the part over here because the shaded region, all the x values are positive. Does that answer your question? Okay. Other questions? Let's take a look at 3. So this one asks both. There's an x and a y. You guys want a second to try it first? First person to speak gets their way. Can't believe it wasn't Ella, but here we are. Okay. So, oh.
I don't really want to try
Don't write in it. So perpendicular to the x-axis. So first of all, I think drawing them is really helpful because it's really easy to see. Am I doing top minus bottom or right minus left? So I'm always going to draw that. It could be there. It could be there. It could be wherever. You only need one. I'm just trying to demonstrate multiple ones. So this is a rectangle whose height is 2 times the width. So the height is like what's coming out of the board at you. So that height is double the width. So you're going to get these pretty tall rectangles coming out of the board. We are perpendicular to the x-axis, so every single thing we put in there has to be an x value. So, volume equals. Left hand x value is 0. Right hand x value is 2. Remember, x equals 2 is a vertical line, so that's that guy. So I'm going from 0 to 2, x values. I've got to integrate the area. So again, I'm going to write down kind of an extra step here that you probably will not write down as you get more comfortable with these. What's the area of a rectangle if the height is 2 times the width? I think when I say it, it sounds harder than it actually is. So I have a rectangle space times height, right? I'm saying that the height, well, let's keep it there language. Area equals width times height. They're saying the height is 2 times the width. So couldn't I do this? If the height is 2 times the width, isn't that like, isn't that just 2w squared? Because if the height is double the width, then you put 2w there. W times 2w will give you 2w squared. So the area of this shape, the volume of this shape, is going to be integrating the area, and the area is 2 times the width squared. Sammy, if you got questions on anything I've done so far. And then the width, we're perpendicular to the x-axis, so it's that distance. Top minus bottom, right? So this top one is y equals x to the third. This bottom one is y equals 0. So this is going to be the integral from 0 to 2 of 2 times the width squared. Well, the width is just top minus bottom, so it's x cubed minus 0. And you are absolutely fine to leave it like that. If you were on an AP test and said just set it up, they might go like this. And you just kind of have to realize they squared that and then multiplied by 2. They just might rearrange it. Questions on anything on that? Where'd you get this from? Why did you do this? Okay. Part B. Now we're perpendicular to the y-axis. So my representative shape is more like that. This is x equals 2. Is that solved in terms of y? Is. In terms of y means x equals. In terms of x means y equals. So that actually is in terms of y. There's just not a y there. And then this we need in terms of y also. So if y equals x to the third, then x is going to equal y to the 1/3. So how big is this little strip right here? What's the size of it? Right minus left. 2 minus y to the 1/3. I mean, if this was at, if this is at 2 and this is at 1, how far apart are those? 1. Right minus left. Same idea. You're doing the right hand thing minus the left hand thing. But I really am not there yet. Is someone asking something? Alright, I'm doing it in y's. So my lower y value is 0. My upper y value is 8, right? And then I want a rectangle whose height is 6. So the area of this rectangle is the width times the height. dy or dx? dy, because these are y values and perpendicular to the y-axis. So the width is what you guys just said. It's 2 minus y to the 1/3. And the height is just straight up 6. It's not like 6 times bigger or 6 more. It's just straight up 6. So your width is this, and the height of all of these rectangles coming out will be exactly the same. It'll be like this part that's 6 units. Question on 3. Yeah. It's telling me in the problem the height is 6. Is that enough? Okay. So you don't need like an equation. It's just like 6. Other questions on 3? Okay. Let's do 4. Actually, let me show you something on 3 first. So where you're headed on your next test will look like this. I'll give you a shape, and I'll probably ask you to do 6 things to it. Find the area, set up, right? Set up the area with respect to x. Set up the area with respect to y. I'll ask you to find a cross section perpendicular to the x-axis of some shape. I'll ask you to find a cross section perpendicular to the y-axis of some shape. So that's 4. And then what we're doing next week is we start revolving these shapes. So imagine that shape is revolved around that line. So it kind of comes out of the board, makes like a circle type thing, goes back into the board, if it's just twists through and comes back out, and makes like this revolved shape. And I'll probably ask you to do one of those perpendicular to the x and one of those perpendicular to the y. I'll give you another shape and like do these 6 things. So that's what most of the test is. So let's go to 4 because that one doesn't have a graph. I don't think that's a huge issue at this point, but let's do it. You don't have a calculator on this one either, let's say. So we are perpendicular to the x-axis. Means we need to be in terms of x. Are we in terms of x right now? Yep, in terms of x means solve for y, so that's in terms of x. So I need to find my left and right bound where those intersect. So first I gotta go, okay, x squared minus 4 equals 2x minus x squared. If you got your calculator, just throw it in the solver, but let's say we don't have it on this one. But I gotta solve that, so I think I would bring that over and make it 2x squared. Bring that over, make it negative 2x, and then you got your minus 4. Which looks annoying to factor at first, at least for me. And then if I take a 2 out, it all of a sudden looks a lot nicer, at least to me. So that's going to be 2 times, and then x minus 2x plus 1. You good? You with me? And then like 2 equals 0 never happens. X minus 2 equals 0 happens when x equals 2. X plus 1 equals 0 when x equals negative 1. So we've got between negative 1 and 2 is going to be our integral. Alright. Now I've got to know they're going to be squares. So the area of a square is the length squared. We are perpendicular to the x-axis, so we're going this way. So what's the distance of one of those cross sections? How far apart are the 2 equations? Top minus bottom. I don't know yet what's on top. So I'm going to take a second to figure that out. So what I want to do is put top minus bottom in place of that number. I need to pick a number in between these 2 numbers. So let's say 0. Plug it into both. So if I plug 0 in here, I get negative 4. If I plug 0 in here, I get 0. So that one's bigger, which means that one's on top. So then top minus bottom is 2x minus x squared minus x squared minus 4. And that's the length, and then that gets squared to give you a square times dx. How's that one? Great. Not quite great. Can I help? Is this like an answer, or you just gotta like do it in practice? Oh, that isn't there. Yeah. I'm all set unless you guys have questions. It's just time to do the work. Let me see which ones you're doing. do they all just say set up? Don't solve. Don't solve. You're doing 1 through 10, but you're not solving them. You're just setting them up. We'll probably do them tomorrow. So don't like cross them off.